You are welcome to today's episode of JAMB Must Repeat Question. I'm making a promise to you that you see this question on the screen, you are going to see this question in your JAMB UTME 2026. So what do you have to do as a smart student? As a smart student, get your pen and your paper to jot whatever you understand down. Pen down whatever you understand because you are going to need it for subsequent revision in your JAMB UTME 2026. So maybe when it's 3 weeks to your JAMB UTME, you bring out what you have jotted, all you have penned down to study or to revise for your JAMB UTME 2026. Now let's look at this chemistry question because this question you are definitely going to see this question in your JAMB UTME 2026. This question is in JAMB 2026 syllabus and JAMB doesn't joke with electronic configuration. The question reads, the electronic configuration of an atom of nitrogen is YS2, 2S2, 2P1S, 2P1Y, 2P1Z because the atom is what? Option A, in an excited state. Option B, undergoing energy changes. C, unstable and ready to combine with another. D, simply obeying the rules governing electron configuration. What's the answer? Let's find out. First of all, we have to understand the rules of electronic configuration, the rule that guides electronic configuration. And looking at what we have here on the screen, the rules governing electronic configuration are the AUFBAU principle, PAULI's exclusive principle, and the HUND'S rule. These are the three rules or the three laws that govern electronic configuration. And we are going to discuss these three rules. We are going to do it as quickly as possible, as simple as possible. Now, let's look at the AUFBAU's principle. And what is in the AUFBAU principle? It states that electrons fill the lowest energy orbital first. So the AUFBAU's principle states that during electron configuration, electron fills the lowest orbitals first. So from the lowest orbital before you go to the higher orbital. Let's look at the Pauli's exclusion principle next. Pauli's exclusion principle. What does it state? It states that no two electrons can have the same spin in one orbital. Each orbital can hold a maximum of 2 electrons with opposite spin. So no two electron is going to have the same what? Spin in electron configuration. Okay, each orbital holds a maximum of what? 2 opposite spin. That's only a maximum of 2 opposite spin. It can never be more than 2 opposite spin. The arrangement, 1 up, 1 down. 1 up, 1 down. That's the spin that it's talking about. 1 up, 1 down. When you take my lecture on electronic configuration, you are going to see the diagrammatic representation of electronic configuration. You are going to see an arrow up and an arrow down. If you have not taken that lecture, please tap on videos and search for that lecture and take it. Okay, so that's the spin that Pauli's is referring to. So maximum spin only 2. Can be 1 up and 1 down. Only 2 maximum spin. And it does not take more than what? 2 electrons in one orbital. That's in that box that you normally put those spin. It does not take more than 2. Okay, it does not take more than 2 in one orbital. Remember, electronic configuration occurs in the subshell level. Okay, electronic configuration occurs in the subshell level. And let's look at the final or the third rule that governs electronic configuration. And that third rule is the HUND'S rule. And the HUND'S rule states electrons fill empty orbitals singly before pairing up in the same sub-level. So electron fills what? Fills empty orbitals singly. That's one by one into empty orbitals singly, pairing up in the same sub-shell level or suborbital level. Now that we have understood the principle of electronic configuration, let's go back to the question that brought us here. JAMB must repeat question. The question reads, the electronic configuration of an atom of nitrogen is 1s2. Look at the electronic configuration they placed here. 1s2, 2s2, 2p1, 2p1y, 2p1x, 2p1y, 2p1z. Because the atom is, when you look at this electronic configuration here, you are going to notice that from here we have X or X, then here we have Y, and here we have Z. This represents the orbitals. Okay, remember the HUND'S rule. Let's go back to the HUND'S rule. The HUND'S rule states electron fill empty orbital singly. That's one orbital that is empty singly before pairing up in the same sub level. Okay, let's go back to the question. Can you see what we have here? 2p1s, that's singly. This electron is filling the orbital singly. Okay, 2p1s, 2p1y, 2p1z singly. What's your answer? Among the options, the first option here is in an excited state. That is obviously wrong. That's not the answer. Let's look at option B, undergoing energy changes. Is that the correct option? That is obviously the wrong option. Let's look at option C. Option C, unstable and ready to combine with another, which is also wrong. For your correct option, option D, simply obeying rules governing electronic configuration. That's the correct answer. Shaking, huh? simply obeying the rules governing electronic configuration. So this electronic configuration, or this expression given to us here, obeys the rule or the HUND'S rule of electronic configuration. JAMB must repeat question 2. Based on popular demands, a lot of students have been begging I explain this question to them so that they will understand, because a lot of students entered one class as a result of this question. So I'm a good guy. I will always teach you. I will always explain to you. I will always make you pass. I have your good at heart. So what do you have to do as a smart student? Because you are definitely going to see this question in your JAMB UTME 2026, because you have it in JAMB syllabus and it's part of the high yield, always repeated, one of the most repeated questions in JAMB UTME. So what are you waiting for? Get your pen and your paper. This is the right time to prevent your village people from succeeding. They are not going to succeed. You are going to be the one to succeed. Neither will your village people succeed. Your village people shall not bring their wicked plans into your JAMB UTME 2026. So get your pen and paper for your notes, the notes that you are going to make. Get your pen and your exercise books and let's go. The question reads, the term strong and weak acids is used to indicate what? The term strong and weak acid is used to indicate what? The first option we have here is A, number of hydrogen ion released by an acid. B, number of hydroxide ion released by an acid. C, extent of ionization of an acid. D, strength of its action on substance. JAMB 2026 candidates, what's your answer? Let's find that out. Strong acid. And what are the lists of strong acid? We have strong acid, for example, we have the hydrochloric acid, it's a very strong acid. We have nitric acid, also a strong acid. We have sulfuric acid, which is the hydrogen tetraoxosulfite 6 acid. 3 of them, they are all strong acids. Now that we have seen some examples of strong acids, let's now look at the characteristics of strong acids. How do we know a strong acid when we see them or when we come across them? The first one we have here, the first characteristic is they ionize fully. They ionize what? Fully when dissolved in water or in a polar solution. They ionize what? Fully in water or in polar solutions. The second one we have here is they have a high concentration of hydrogen ion, very high concentration of hydrogen ion. The third we have here is they show high electrical conductivity because they are highly ionic. The fourth we have here is they have very low pH value, usually between 0 and 1. That's it. And the final one we have here is they react vigorously with reactive metals, bases, and carbohydrates. These are the characteristics of strong acid. So I know that you know the answer to the question now. I know that you figure out the answer to the question. So if you have figured out the answer to the question, it's time to reattempt that question. So remember, there are two types of acid. You have the strong acid and you have the weak acid. And between these strong and weak acids, their level of ionization is divided into 3. Acid can either ionize completely, or ionize slightly, or ionize partially. Either they ionize slightly, partially, or completely in polar solutions such as water. Acids ionize in 3 ways. Either they ionize partially, completely, or slightly in a polar solution. So strong acids ionizes completely. That's why they are called strong acid. They ionize completely in a polar solution. Why moderately weak acid is an acid that ionizes partially. Okay, so it ionizes partially, not so strong, but partially. So it's a moderately weak acid. Then the weak acids, they ionize only slightly. That's why they are called weak acid, because of that slight ionization. For example, I'll give you an example of a weak acid. A weak acid is ethanoic acid. That's a weak acid. So a weak mineral acid. So it ionizes slightly in water. Now let's go back to the question that brought us to this explanation. The question reads, the term strong and weak acid is used to indicate what? A, number of hydrogen ion released by the acid. Is that correct? That's obviously wrong. Remember what we just discussed. Let's look at option B. Option B reads number of hydroxide ion released by an acid. No, that's obviously wrong, because hydroxide ion is usually specific to base. It's particular to bases and alkalis. Okay, so option B is obviously wrong. It is not part of the characteristics discussed. For your correct option, option C, the extent of ionization of an acid. That's the answer, Shikina. So the term strong and weak acid, what determines if an acid is going to be called a strong acid, going to be called a weak acid? The extent to which it ionizes in water or polar solvents. Remember, I told you that there are 3 types of acid ionization. Acid either ionizes slightly, partially, or fully. So, and the ones that ionizes fully are strong acids. The ones that ionizes only slightly. The ones that ionize completely are called strong acid, while the ones that ionize slightly are called weak acid. So how do you differentiate a strong acid from a weak acid? Simply by its extent of ionization. That's the answer. Thank you so much for taking this lecture. JAMB 2026 candidates, I will see you in the next video for the JAMB must repeat questions. Congratulations on earning this mark, and I wish you good luck in your JAMB UTME preparation. Peace!